In section 6.3, we are simplifying radical expressions, and there are two objectives: to multiply and simplify radical expressions, and then in part B, we divide and simplify radical expressions. So the basis for that is the product rule for radicals. And so for any non-negative real numbers a and b and any index k, the kth root of a times the kth root of b is the kth root of the product of a and b. Or, in exponential notation, a to the 1 over k plus b to the 1 over k is equal to ab to the 1 over k power. And that's to multiply the radicants. So let's do that here with a couple of examples. Number 1. So that means that's equal to the radical of the product of 19 and 7. And that would be equal to 133. So it's simply the square root of 133. 19 times 7. Or example number 2. It's the square root of 7 times 3 is 21. And then the product of p and q, square root of 21 pq. So for number 3, that's equal to the square root, to the fourth root of 403 times 7, and that's equal to the fourth root of 2,821. So that would be the answer to number 3. I don't think I can squeeze the answer in here, so I'm just going to leave it over here. Similarly, for number 4, the indices are the same. So that's equal to the square root of 5 times 2 is 10, third root rather, divided by p times q. So for number 5, we write this as 5 to the 1/2 power times 2 to the 1/3 power. And now we need to have the same common denominator, so we need to multiply 1/2 times 3 divided by 3. So that becomes 5 to the 3/6 power. And we need to multiply here the numerator and denominator by 2, so times 2 to the 2/6 power. So that means 5 to the 3rd power times 2 to the 2nd power to the 1/6. And that's equal to 5 to the 3rd is 125. And 2 to the 2nd power is 4 to the 1/6 power, 1/6. So that means it's a 6th root, and 4 times 25 is 500. So that the answer here is the 6th root of 500. So for number 6, we have the fourth root of x means x to the 1/4. And the third root of 2y means 2y to the 1/3. To combine these exponents, we have an LCD of 12, so we need to multiply the first exponent by 3 divided by 3, so it becomes x to the 3/12. And this exponent we multiply by 4 divided by 4, so it becomes 2y to the 4/12. So that means this expression is equal to x to the 3rd 2y to the fourth all to the 1/12th power. And that means we have the 12th root of x to the third, and 2y to the fourth is 2 to the fourth times 2 to the fourth times y to the fourth, and that is equal to the 12th root of 2 to the fourth is 16, x to the third, y to the fourth. So that's what this expression is equal to. It is the 12th root of 16 times x to the third times y to the fourth. We can also factor radical expressions, and so here we have the rule for any non-negative real numbers a and b, and any index k, the kth root of ab, the kth root of the product, is a product of the kth root of a times the kth root of b. Or in exponential notation, ab to the 1/kth power is equal to a to the 1/kth times b to the 1/kth. That's simply the product rule for exponents. So in other words, you take the kth root of each factor separately. So here are the steps for simplifying kth roots. Look at the largest factor of the radicand that are perfect kth powers, where k is the index, and then take the kth root of the resulting factors. And a radical expression with index k is simplified when its radicand has no factors that are perfect kth powers. That may sound a little bit confusing when you read it, but as we get to do it, it becomes more clear. So when we look at number 7, simplify by factoring, so for number 7, the greatest perfect kth power would be 16, so we can write 32 as a square root of 16 times 2, and we can write that as the square root of 16 times the square root of 2, and the square root of 16 is 4 times the square root of 2. So that's the answer for this one, 4 square root of 2. And number 8 is very similar. We can write 80 as 8 times 10, or the cube root or the third root of 8 times the third root of 10. And the third root of 8 is 2, because 2 to the third equals 8, times the third root of 10. So that's the answer for this one, 2 times the third root of 10. So here's another important observation. Frequently, expressions under radicals do not contain negative power of numbers raised to even powers. In such cases, absolute value notation is not necessary. So here's the bold print. For this reason, we will no longer use absolute value notation. So that's why you won't see it in the future here. So number 9, we can write as the square root of 100 times 3, which is equal to the square root of 100 times the square root of 3. And so the square root of 100 is 10 times the square root of 3. So that's the answer for number 9, 10 times the square root of 3. And we can write 36y squared as 6y squared. So then the square root of 6y squared is simply 6y. Number 11 we can write as the square root of 9 times 3 times z times w squared. And we can write that as the square root of 9 times the square root of w squared times the square root of 3z. And the square root of 9 is 3. The square root of w squared is w. And then here's the square root of 3z. So that is then the answer to number 11. So it's 3w square root of 3z. And for number 12 rather, the cube root of 16 we can write as a cube root of 8 times 2. 8 times 2 is 16. So that would be the cube root of 8 times the cube root of 2. And the cube root of 8 is 2. So it's 2 times the cube root of 2. So equals 2 times the third root or cube root of 2. So number 13 is a guided solution problem. So 12 we can factor as 4 times 3. And then we have a b to the third, so it would be another b here, times c squared. So now we can write this as square root of 4 times the square root of b squared times the square root of c squared. And then there's an a and a b and a 3. So 3ab. So the square root of 4 is 2, the square root of b squared is b, and the square root of c squared, of course, is c, times the square root of 3ab, and that would be our final solution, 2bc times the square root of 3ab. And so number 14 is very similar. So we can write it as follows. So here we can factor the radicand as follows. So third root, and we can write 81, that is 3 to the fourth, so 3 to the third times 3. And we write x to the fourth as x to the third times x. And y to the eighth, you write as y to the sixth times y squared. So in other words, the expression is still the same, the variables, and as far as the coefficients are concerned. But now we can write this as the third root of 3 to the third times the third root of x to the third times the third root of y to the sixth times the third root of 3xy squared. Now we know that the third root of x to the third is 3, and the third root of 3 to the third is 3, and the third root of x to the third is x, and the third root of y to the sixth is y squared. So then it's times the third root of 3xy squared. So that's the answer to this one. 3xy squared, 3xy squared times the third root of 3xy squared. So the idea is to factor things in such a way that you have powers of third. And of course, y to the 6 is the same as y to the third squared. So 6 is a factor, or 3 is a factor of 6. So for number 15 and 16, we have to multiply and simplify. Assume that no radicals were formed by raising negative numbers to even powers. So then that means that the square root of 3 times 6, or the square root of 18, and we can write 18 as 9 times 2, so the square root of 9 times the square root of 2, and the square root of 9 is 3, so it's 3 times the square root of 2. So that would be the answer for number 15, 3 times the square root of 2. So for number 16, we can write square root of 18y as the square root of 9 times 2 times y. And 14 we can write as 7 times 2 times y. So we can see now that we have a square root of 9, and 2 times 2 is 4, and y times y is y squared, and then there's 7y, 7 times y. So 9 times 4 is 36, so square root of 36 times the square root of y squared times the square root of 7y, and the square root of 36, of course, is 6. The square root of y squared is y, and then we have the square root of 7y. So that's then the answer to number 16, 6y times the square root of 7y. Number 17 is the guided solutions. We write these expressions under 1/3 root radical symbol, so times 36x, and that becomes 3x times x times y times 2 times 2 times 9, or 3, so 3 times 3. So we have 3x squared y times 4 times 9, 36x. So now we have 3 times 3 times 3, and the third root of 3 to the third is 3, and we have x times x times x, which is x to the third, and the third root of x to the third is x, and then here we just have a y and a 2, so we have 2y, or 4y actually, 4 times the y. So that's then our answer, 3x times the third root of 4y. In number 18, we rewrite the expression as radical 7a, and we factor 21 as 7 times 3 times b. So now we have 7 square root of 7 squared, and then there's a 3ab, 3ab. So that's the square root of 7 squared times the square root of 3ab. And of course the square root of 7 squared is 7 times the square root of 3ab. So that's the answer to number 18. 7 times the square root of 3ab. So now we come to our second objectives, dividing and simplifying radical expressions. And so here's the quotient rule for radicals. For any non-negative numbers a, any positive number b, and any index k, the kth root of a divided by kth root of b is the kth root of the quotient of a and b, or a to the 1 over k divided by b to the 1 over k is equal to ab to the 1 over k. ab, of course, in parentheses. So to divide the radicands. After doing this, so you can sometimes simplify by taking roots. So we take a look at this in just a moment here with some of the examples. Let's look at number 19. From the rule we just said above here, we can rewrite this expression as the square root of 75 divided by 3. And we know that that's equal to 75 divided by 3 is 25. So that's the square root of 25, which is equal to 5. So that's the answer here. The expression number 20 says basically 14 divided by 2 times the square root of 128xy divided by the square root of 2. So first of all, 14 divided by 2 is 7. And now we're going to rewrite the square root as the square root of 128xy divided by 2. So that's equal then to 7 times the square root of 128 divided by 2 is 64 xy. And we know that that's equal to 7 times the square root of 64 times the square root of xy. And the square root of 64 is 8, so we have 7 times 8 times the square root of xy. Or finally 56 times the square root of xy. So that's our answer to number 20. So 56 times the square root of xy. We can rewrite the expression number 21 under one radical symbol, the square root of 50 a to the third divided by 2a. And so 50 divided by 2 is 25. And a to the third divided by a is a to the 3 minus 1, or a squared. So that's equal to the square root of 25 times the square root of a squared. And the square root of 25 is 5, and the square root of a squared is a. So the answer is 5a. So for number 22, we can rewrite the expression as 4/7 times the third root of 250 divided by 2. which would be 4/7 times the third root of 125, and that's equal to 4/7 times the third root of 5 to the third, and the third root of 5 to the third is 5. So then the answer is 5 times 4 is 27. So that's equal to 27. For next three examples, we have to simplify by taking the roots of the numerator and the denominator and assume that no radicals were formed by raising negative numbers to even powers. So we don't need absolute value symbols. So in other words, for number 23, there would be the square root of 25 divided by the square root of 36. And the square root of 25 is 5, and the square root of 36 is 6. So that's equal to 5, 6. Similarly, for number 24, we can rewrite this as the square root of x squared divided by the square root of 100. And the square root of x squared, of course, is x, and the square root of 100 is 10. So x divided by 10 is the answer to number 24. Now, for number 25, it's a little more complicated. So we need to think about that. But here the idea is to rewrite this as the third root of 54x to the fifth divided by the third root of 125. Now we know the third root of 125 is the third root of 5 to the third. For the numerator, we need to be a little more creative. So third root. And so 54 can be factored as 27 times 2. So 27 times 2. And x to the fifth we can write as x to the third times x squared. And so 27 is equal to 3 to the third. And then we have x to the third. And we have 2x squared times 2x squared divided by the third root of 5 to the third is 5. So then for the numerator, the third, we can take one extra step here. The third root of 3 to the third times the third root of x to the third times the third root of 2x squared divided by 5. And so the third root of 3 to the third is 3. And the third root of x to the third is x times the third root of 2x squared divided by 5. So this then is the answer for number 25. 3x rather, not 3x to the third, 3x times the third root of 2x squared divided by 5. So this is the index, this 3 here. So this is the answer, 3x times the third root of 2x squared divided by 5, and here's a derivation. So number 26 we can write as x to the third y squared to the 1/4 power, and in the denominator we have x squared y to the 1/3 power. So we want to make the denominators the same, so we need to multiply this by 3 divided by 3, so it would be 3/12, so it would be x to the third y squared to the 3/12 power, and in the denominator we have x squared y, so here we need to multiply by 4 divided by 4 to get a 12 in the denominator, so 4/12. So now we have the same denominator, which means we now have the 12th root of x to the third y squared raised to the third power divided by x squared y raised to the 4th power. So that's equal to the 12th root of x to the third raised to the third power is x to the 9th, and y squared raised to the third power is y to the 6th. In the denominator we have y squared to the 4th x squared to the 4th is x to the 8th, and y to the 4th. So now we can divide the expression in the under the radical sign, the radicand. We can simplify that. So we have the 12th root of, and x to the 9th divided by x to the 8th is x, and y to the 6th divided by y to the 4th is y squared. So in other words, it is the 12th root of x y squared. So this simplifies to the 12th root of x y squared. So the index is 12. And this concludes section 6.3.